Okay, 10.3, circles. So I'll keep this short because I think you guys did really well with this in class. Basically, the first definition was a circle, something that you guys are all familiar with, is the set of points, right, that are all equidistant from a fixed point, which would be the center, that's what we call it, and the distance from, so here is my center, and the distance from this guy. So the distance from my center is, hold on, I need my pen. The distance from the center to any point on the circle is called my what? That would be my radius, alright? And since we're looking at this on the coordinate plane, we can see that the radius, we can just count on one of the, like on the x-axis or the y-axis, and by counting here, we see that this is 5 units, so my radius here would be 5. And then we also learned that the standard form of an equation like this is, of a circle like this, is x squared plus y squared equals r squared. So a circle whose center is on the origin at 0, 0, this is the standard form. Now, the first thing we did 3 things. We graphed a circle given an equation. So we said the standard form was x squared plus y squared, those are squareds, yes they are, I'm sorry, equals r squared. Now, what's the problem here? Why can't we graph this one? What do we have to do first? We need to make this look like this. So in order to do that, we need to move my little friend here, x squared, over here. Sorry, I covered up your little 25 there. Okay, let's fix that. Alright, so since we have minus x squared, to move that over, what we need to do is we need to add x squared, okay, to both sides. So if I add x squared, now what's my new equation? We have x squared plus y squared equals 25. Okay, so now we're good? Alright, it's in the right form. Now, like we said, the 25, that represents r squared. So that means, so let's write that down here. So now that means r squared is 25. So to find r, we would just have to take the square root of both sides, so r equals 5. So to do this, just pick the most convenient points possible. So what you would do is look at the x-axis and the y-axis, and you would just plot, 5, 0, negative 5, 0, alright? And basically, we can just use, we can use this fancy stuff here. Alright, I'll just drag this a little bit. Don't want to waste too much time on this, though. Okay. This is fancy. Alright, look at that. So that's my circle. Now, the next thing that we did is to write the equation given a circle whose center is the origin, and they give you a point that's on the circle. Okay, so my origin is this thing right here. Alright, this is my origin, right? Now, we know 1, 4, so 1, 4, that's a point. Now, we said on the circle, the distance from the center to any point, that's your radius, so that's r right here. But r is, I don't like that line, let's delete it. Okay, so let's look here. R right here, it's not along any of the, so you can't really tell, you can't count here and see how big r is, so we need to do the distance formula we did in section 1. Now, if you don't remember it, don't worry, not a big deal. We said the distance formula is really just Pythagorean theorem. So here, one of your legs of your right triangle is what? 1. Okay, so we got 1 squared. Now, okay, I need my pen back. Alright. So, 1 squared, right? Now, let's look at my other leg of this right triangle. It is, how many? 4. 4 squared. And that's equal to the hypotenuse of this triangle, which is just r. So that's r squared. Now, in order to get r alone, what we have to do is take the square root of it, right? And look how nice my distance formula. Didn't even have to remember it, alright? No memorizing, just understand where it's coming from. So now, let's do this. The square root of, what's 1 squared? 1 plus 4 squared, 16. So 1 plus 16, 17. So r equals the square root of 17. Now, the standard form, like we said, is x squared plus y squared equals r squared. Plug square root of 17 in. Square root of 17 squared. What's 17 squared? Just 17. So your final answer would just be square root x squared plus y squared equals 17. How nice. Alright. The last thing was, okay, so they want you to give the equation of a tangent line to the circle, this circle here, x squared plus y squared equals 13 at point 23. So what you need to do is find the radius, which would be the square root of 13. So that's going to be, a little bit between 3 and 4. Alright, so just, you can put in your calculator, approximate what it is. So I'm going to say around here, okay? So now let's draw our fancy little circle. Okay. Okay, so it should go through about 3, 4, between 3 and 4, excuse me. Okay, that looks good. Now, the point 2, 3, let's find that point. So just graph every single thing that they give you. This will help you. 2, 3, right here. So it is a point on the circle. That's good. Now, what you want to do is, they say the tangent line. So if I was to draw in my radius, so let's do that in green. This is my radius, right? The tangent line is always perpendicular, and it's going through that fancy little point. So this would be the tangent line, this guy right here. So what's my slope of the radius? What would be the slope? So to do that, we know that this guy here is 0, 0, right? And we know that this is 2, 3. So I can find the slope of the radius. So the slope of my radius, alright, let's kind of color code this, would be so subtract the y coordinates, so 3 minus 0 over 2 minus 0, right, which is just 3 halves. So if the tangent line is perpendicular, what's the slope of the tangent line? The opposite reciprocal. So the slope of the tangent line would be negative 2/3. Alright, so now look at this. I have the slope of the tangent line. I have a point on the tangent line. So what you can do is use the point slope formula. So y minus y1 equals the slope, negative 2/3, times x minus x1, which is 2. And then you would go through and simplify, and your final answer would be the simplified version of this. And we are done.